Okay, today's notes we're going to be talking about section 1-1 rational numbers and decimals, and our goal here is how can I write repeating decimals as fractions. A couple of things that I think we need to clarify before we kind of get into how we can complete this is a couple of vocabulary terms. The first term is just the idea of a rational number. All right, and these are numbers that can be written as a division problem. And what that really means is they can be written as a fraction. That's all it means. Repeating is another term. And these, in terms of what we're working with now, repeating means decimals that repeat a specific pattern forever. And then the opposite, maybe not the opposite, but another type of decimal would be terminating. These are decimals that end or stop in general. All right. So what we're going to do here is we're going to take an example of a decimal like 0.5 repeating, and we're going to turn this into a fraction. All right. This is a little bit tricky. All right. So we have to follow specific rules. All right. The very first rule or step is for us to write an equation where the variable equals the decimal. All right, so I can just say that it is x equals 0.5 repeating. All right, so that's what that first step is. Take that information, make x equal that. So I'm telling you right now that x equals this, this specific number. All right, from here, we're going to get a little bit more difficile. We're going to multiply each side of this one-step equation, essentially, that it looks like right now, or just equation, by 10 to the power of d, where d is the number of decimals repeated. All right, so on this specific example, we have one number being repeated. So what that means is we're going to multiply both sides by 10 to the first power. All right, 1 is the d because there's one number being repeated. All right, so then we can now evaluate that. 10 to the first is really just 10, so this turns into 10x. 10 to the first, so really 10 times 0.5 really turns us into 5.5 repeating. All right, 0.5 repeating times 10 really is, 5 point something, but that something is this 5 being repeated over and over and over and over again. All right. Then, this is where we really start getting tricky. We're going to subtract equivalent expressions of the variable and repeating decimal. From each side. What that's telling us is we're going to just subtract this, really 1x from this side, and we're going to subtract what this is 0.5 right here, okay? So I'm just going to subtract that 1x that we have right here, and I'm going to subtract 0.5 repeating from here. So that gives me 9x equals, when I subtract those, I'm really only just left with 5. So now I'm just going to solve the equation. So we'll divide by 9 on both sides. And x equals 5/9. So 0.5 repeating is 5/9 as a fraction. It's not 5 over 10. I know 5's in the tenths place. So if I went 5 divided by 10, that's 0.5, not repeating. But if I went 5 divided by 9, I get that 0.5 repeating. That's how we get there. All right. Now, it might be easy for you, at an example like this, you look at it and say, okay, it's 0.5 repeating, 5's in the 10th place, I'm going to subtract 1 from the 10th place, and it's going to be 5 over 9. All right, that is all right and easy to use for these types of examples, but they'll get a little bit more tricky. All right, so let's go to our next example, 0.26 repeating. So we're going to write an equation where the variable equals the decimal. So x equals 0.26 repeating. Multiply each side by 10 to the d power, where d is the number of decimals being repeated. Since it's 2 of them, it's going to be 10 squared times x, 0.26 repeating times 10 squared. And what that leaves us with on the left side is 100x, and on the right side it's going to be 26.26 repeating. 100 times 26 just turns into 26 point something. That point something is that repeated pattern that we have. We're going to subtract these from both sides. So minus 1x, or x, minus 0.26 repeating on both sides. And that gives us 99x equals 26. So now we're going to solve the equation. So I'm going to now divide by 99 on both sides. And x equals 26 over 99. If I can simplify the fraction, simplify it. This one cannot, I don't think. Let's just double check our little cheat way. Nope, we're good. Or I look at this and see, all right, this is 26, it's in the hundredth spot instead of putting it 26 over 100, because if I went 26 divided by 100, it would just give me 0.26. But since if I go 26 divided by 99, it gives me 26, 26, 26, 26, that repeating pattern. All right. And that part is okay and simple to use, but when I get to an example like 3 here, where I have 2.09 repeated, this is where it gets tricky, and I really have to utilize that rule. All right, so we'll write our equation. X equals 2.09 repeating. We're going to multiply this by 10 to the second power because only these two are being repeated. The 2 is not being repeated, only the 0.9. So it's 10 squared times x, 2.09 times 10 squared. 2.09 repeating. All right, and what that leaves us with on the left side is 100x, just like last example. But on this side, it's going to be 209.09 repeated. I'm going to subtract this from both sides. So minus 1x minus 2.09 repeated. So 100 minus 1 is 99x. This side's a little bit more difficult. These are going to cancel out, but so they're gone, kind of gone. And then 209 minus 2 is 207. Then I need to solve the equation by dividing by 99 on both sides. So I'm left with x equals 207 over 99. I probably can simplify that. As I look at it, I think 207, I can divide by 11 there. Nope, I cannot. Maybe I can divide it by 9. Yep. So that would give me 23 over 11. All right. Where I have a number that's not being repeated, that's where it gets a little bit more difficult, as opposed to just the single or the double number being repeated. All right. Let me know if you have any questions.